Good morning, good afternoon, good evening, ladies and gentlemen. I welcome all of you to this session on decentralized identity for payment sector. Today, we would cover the issues in traditional payments, some novel use cases using self-sovereign identity, biometrics, and couple of other emerging technologies. And finally, we would explore the state-of-art architecture of EarthID. Before moving ahead, let me give you a quick introduction regarding myself. I'm Debajani Mohanty. I work as a SSI expert at EarthID. I'm a blockchain solution architect and I have authored 5 books on blockchain that you can find on Amazon, and my latest work is on SSI. Let's first cover the issues in traditional payment system. Identity theft continues to affect people across the globe, with credit card fraud topping the list in the year 2019 and 20. Overall, more than 9 million Americans have their identities stolen each year, and that's on a steady rise. Hackers get access to victims' credit card details and sell many such numbers wholesale in the dark web. Payment card fraud losses are organized into 5 different categories. We can see that remote purchase, which means shopping on a website or shopping over the internet, occupies the first position, and this has increased in last couple of years. Have you ever thought who pays for the compensation? Well, victims of unauthorized payment card fraud are legally protected against losses. Industry analysis indicates that bank and card companies refund customers in over 98% of cases. Yet, ultimately, it hits the customer's pocket as insurance protection and higher fees. Let's see how such information are stolen. They can be broadly divided into 5 different categories. The first one, hacker may get access to a company's centralized database where credit card information is stored for processing payment. This can affect millions of consumers. Example is Equifax data breach of 2017. Second is skimming, a credit card skimmer, which is a very small device that captures your credit card information from a legitimate transactions. So hackers secretly place the credit card skimmer over the credit card swipe machine at a gas station or ATMs and retrieve the required information. Third one is malwares or viruses. So the hacker trick the user to install a malware software on machines and monitor the user's keystroke or send the screenshots to the hacker. The fourth one is pretty popular, phishing, where the hacker tricks the consumer into giving up credit card information by phone, email, or through fake websites. And final is dumpster diving, where the hacker get access to the credit card information from our receipts that we forget to shred. So what is common among all these cases is that hackers are looking for customers' personal information all the while, which is their digital identity, which they use to commit fraud. So let's now explore what is digital identity. Digital identity is any personal data that identifies you online. We use digital identity during registration, any kind of identity management, login, authorization, and access to online data, and deregistration. Basically, this is needed for initiating any kind of business relationship online. Why to protect digital personal data? Well, out of all the data breaches, personal data theft occupies the first position. Here you can see the top data breaches of all times. It includes some of the biggest names as eBay, Adobe, Anthem. and it has affected hundreds of millions of people. And the data that got stolen were crucial as bank details, credit card details, passwords, etc. The top reason for such theft are centralized server and weak passwords. Let's see how data related to digital identity are stored. The first model that came almost 3 decades back was centralized server, where we used either LDAV or Active Directory or RDBMS to store separate set of user ID and password for each application. The second model is federated identity model, where we use a separate identity provider that has a centralized storage within it with all the credential of users, and it handles the access to several third parties, but both models are vulnerable to mass hacking and single point of failure. Self sovereign identity is a new decentralized model to manage digital identity. Here we have an issuer that issues verified credentials to the user that is saved securely in user's mobile device. At the same time, issuer sends a signed reference hash to the public blockchain. User can share the whole or part of the data to a verifier along with the issuer's public decentralized identity. Now the verifier can check the hash of the data on blockchain to know that if it is valid. The example can be a scenario where issuer is a passport office and verifier is the visa office, and the user sharing as much data needed by the visa office with full consent. At a later point of time, if needed, the issuer can revoke the hash by altering a small piece of data, and the verifier would be able to know that the data is no longer valid. This architecture ensures integrity, ownership, privacy, security, and validity of the data. And please note that there is no centralized storage over here. In real life, there are multiple issuers or certifying bodies or organizations who issue different sets of verified credentials. For example, Alice is born in a hospital that issues the first set of credential. Then she applies for a national identity number, such as Aadhaar in India, which is issued by the government. Then she joins a school or a college that issues the third verified credential. Then she joins an organization as an employee that issues another set of verified credential. The user saves this information to his mobile device most securely, and the user can then share whole or part of this data or in combination from different issuer with a third party as and when needed. The user can share this data in three different modes, that is traditional mode, like I'm sharing my name as it is; zero knowledge proof mode, where I'm not sharing the exact information but sharing only in boolean, like yes or no or true or false. Like if somebody asks me whether I'm older than 25, then I would say yes, so and that would solve their purpose. And at the same time, I'm not sharing my private data, so that is zero knowledge proof and selective sharing. And then finally, the user can share some data in self-attested mode, where the user doesn't need any kind of certification. Like I'm just quoting that my hobbies are such and such, so nobody need to certify that. So those information can be shared on a self-attested mode. And also this sharing happens between the issuers also, like the first issuer would do a background verification and issue the first set of certificate, but all the next issuers would be first the verifiers. They would first check the previous data and then they would issue their certificate, so it works in a chain. um, and then in this architecture, we also have a publicly available blockchain where the issuers would send their reference hashes and the verifiers can read and check whether the data is valid. The SSI ecosystem is usually pretty complex where we have to handle the web standards, the authentication standards, the open source blockchain part, as well as the decentralized identity networks. So mostly the SSI network comes in four different layers. We have a public ledger or a DLT to look after. We have private identity storage, um, and then we got a layer of agent or hub for message transfers, and then client devices for each of the user. The work involved in the architecture of self-sovereign identity is not limited to only data sharing. How would you get access to such a system? Where would we save different type of personal data? Well, for an individual, it's the mobile device or a IPFS device on cloud storage. So here you can see Alice is giving all her data in her mobile device in its natural form or with encryption, whereas Bob is giving his data on his mobile device and a separate copy on IPFS. For the organization, it's all the data can be encrypted and stored on a cloud storage. And then we also have to handle the public ledger, which is responsible for deed creation, reference hash of claims, and revocation registry. Let's explore some use cases. The first one is EarthID's next-gen authentication and authorization architecture. At EarthID, we are using the combination of biometrics and SSI for authenticating users online. Hence, before moving ahead, let's figure out how biometrics works. First, we use a scanner to scan the user's biometric profile, such as the finger, face, iris, retina, or palm vein, and then we extract some unique feature out of it. We map them and save them to a biometric database in form of biometric template. So biometric template looks something like this. It's in binary form 0101 like that. So this part is similar to the registration process where we create a unique user ID and password. At a later date, user can log in using the same biometrics and system matches it against the biometric template saved within it. And we used machine learning to recognize that and compare those two templates. Spoofing is pretty common in biometric matching. Spoofing is a method of fooling a biometric identity system where an artificial object like a fingerprint mold made of silicon is present to the scanner, which leads the hacker to get access to authorized data and services originally meant for the rightful owner. So, how can we avoid spoofing? By using anti-spoofing mechanism that gives the user a challenge. Like if you are using your face as your biometrics, then the scanner would ask you to smile or turn your head. If you are using iris, it could ask you to blink your eyes. If you are using fingerprint, the sensor would check the temperature and pressure of the impression. And of course, there is a machine learning algorithm to study the high quality images. At EarthID, we are blending biometrics and SSI for next-gen authentication system. The user's biometrics would be captured only on the mobile device and it is stored here. During registration, which happens only once, the biometric template can be sent to the issuer. Here, if needed, perhaps for a national identity program, there would be a round of background verification for the user, deduplication, and template can be saved for identity creation and matching in future to make sure that multiple fake identities cannot be created by a single person. For most of the use cases, this step would not be needed. Finally, the issuer would send a hash to the public blockchain, signing it with their own private key. Later, the issuer can log in to the same organization or a different organization that trusts the first organization, again from the same mobile device where the template matching would happen. And the verifier would just check that the hash that is passed to it is matching with the version on the blockchain issued by the issuer. For this use case, we are using face, iris, fingerprint as the biometric at the moment. In future, we have the plan to use behavioral biometrics as voice and gait. Now, let's explore EarthID's novel and very interesting use case of privacy preserving payments, which means that you are paying using your credit card or debit card and yet not revealing any personal data with the merchant. But is that possible? Let's see. I believe that all of you are aware how traditional payment system works. Here, when you purchase anything online or offline, you have to share your credit card details on merchant's web server, from where it goes to a payment gateway and then to the bank, from where the amount goes to the merchant's account. Now let's explore EarthID's privacy preserving payment architecture. In this use case, let's say that the user has an account with this well-known bank. Now the user is visiting a restaurant in person or visiting a website on internet where he is ordering for some delicious ice creams. Now the restaurant or the website asks for payment with the amount to pay, the merchant's account details, and a unique reference number. The user sends an instruction to the bank with all these details for payment. The bank does the payment and sends a confirmation, and at the same time sends a reference hash to the public blockchain, signing it with its own private key. The user shares those details to the merchant. The merchant checks the reference on the blockchain and delivers the ice cream. Here, you are able to generate the trust for the payment confirmation and at the same time not revealing the credit card details of the user with any third party. The next use case is on demand location tracking for fraud protection. I believe we all are aware how location tracking works either for an individual or a vehicle through a mobile device. Now, let's go to the details of this use case. Location tracking is pretty useful to combat fraud in the world of payment. However, it raises high concern among many people over privacy and misuse. In this slide, you can find some of the extracts from a very recent report by payments.com where they have mentioned the reasons why people are not willing to share their location information. Especially the elderlies are the most reluctant ones due to privacy and safety concern. They are also the group of people who are most targeted for credit card frauds. Now let's explore EarthID's on-demand location tracking with SSI use case. In this use case, you can find that the user is doing some payment and only at that time the user is requesting its network service provider for verified location details. Now the network service provider would keep on sending hashes of location details of the user from time to time to the public blockchain and only after receiving a request. And then it returns the location credentials to the user. The user then can share the location data with the payment provider during the payment. The payment provider can check the hash and know that whether it's matching with the users' provided details. Doing so, the payment can be completely fraud proof. The final use case is of biometric cards for payment. I believe most of you might have heard of biometric cards. Many banks started dispatching such cards to their customers. Now let's explore how such a biometric card works for payment. Biometric cards are extremely secure. You have to visit your bank and prove your identity. They would issue you a blank card with a sensor and all mechanism to capture biometrics with liveness detection test. So how that is done? Because each card has got a inbuilt sensor that can even check the temperature and pressure of a fingerprint. So with this mechanism, your biometric template would not be sent over the internet or stored on the server, but it would be there only saved on the card, and it would be matched on the card itself while you do the payment either in a shop or you visit a ATM for cash withdrawals. Hence, there is no possibility of man in the middle attack with this approach. So this is a very new use case, and there are banks who have started dispatching biometric cards to their users. Biometric cards are a very novel product in the market, and many of us are not sure what kind of issues and frauds it might bring in. Hence, we are trying to introduce on demand location tracking with SSI to give this card additional security. We are still exploring this use case, and there can be additional possibilities in future. Okay, so we went through quite a few of our novel use cases. Now let's explore EarthID's area of research. At EarthID, the factors that we consider for SSI success and global adoption are as below. First of all, the SSI network should be integrated with biometrics, and that should be a very strong area. Scalability and throughput should be high because it's in SSI we are dealing with users who are people like you and me, and devices in future. Like each person can be having more than one device. So that is why we are talking about a scalability of not 100 or 1,000 but maybe millions or even more. Um, Cybersecurity should be good enough, interoperability should be good enough. Your identity network should be easily integratable with other decentralized identity network. The selective disclosure and zero knowledge proof should be a distinguishing feature. Now, how good you have made it work. So that would make sure that you are able to share your data in different modes. And then who are your validators? Like uh, in most of the networks, people ask me that who are your validator nodes? That means who are the organization who are involved in the public blockchain to allow the transactions or maintain the transactions. So these are some of the SSI success factors. Here is the system architecture of EarthID. We are aligning with market leaders and best of the breed biometrics providers and trying with different type of biometrics which are most accurate and can be used with existing smartphones without the need of additional equipment such as sensors. We are using Hashgraph as our public blockchain, which is known for its high cybersecurity features and also high scalability and throughput. It has been tested with 10,000 transactions per second and 1.5 million transactions per day and still counting. This is exactly what is needed for a decentralized identity platform that would need to cater to millions, if not billions, of users in future and also their devices for uh, uh, data communication and data sharing. Also, Hashgraph's validated nodes are run by industry leaders from each business vertical, such as Google, IBM, Deutsche Telekom, Tata Telecom, FIS, Wipro, etc., who already have a lot of trust in the market. So I hope you liked the session. For any queries, you can always approach EarthID or send me a note on LinkedIn. Thank you so much.